So today we're going to do question number 4 of our NeetCode 150 playlist, which is Group Anagrams. It is the 49th question of LeetCode. So what are the questions here? Let's say we have an array of strings: eat, tea, tan, and ate, nat, and bat. So in the second video we already did check anagrams. If we are given two strings, we check if they are anagrams or not. So in this question it says group anagram. So what we want in this string, we can see that EAT, EAT and EAT. So this is a group. So we write it as a group: eat, tea and tan. This is an array. Now we see TAN and TAN. So this is also a group. So we write this in a group as well: TAN and AT. And this one is alone, no similar pattern. So we just make a new array of this, BAT. And this is the array we have to return, because we have made groups of anagrams. It is group 1, group 2 and group 3. So now how to do it? First of all, the brute force. Brute force, as usual, we will check every pair, every possible string with every possible other string by doing like extreme knife solution, doing an own n square 2 loops. So let's start. What we do is we assume that each string is a group of its own. So let's take group number 1 as the eat pattern. So whichever string is similar to this, which is an anagram of this, we will just add it to this group. Okay. So let's start it from here. And now there is also a visited array. Let's make it above. There is also a visited array of boolean with same length as this array, so that we know which strings we have checked. So we are on eat right now. So we do true. We do true here. That means we have checked eat. Now we see t. We already did this question in question number 2. So let's say that function is called check anagram. Okay. So now we are at t. We will call the function for these two strings, eat and t. And if it returns a true, then that means t is also in this group. So we add it and we do true here also. That means we have checked the string once. So that means this won't be in another group and we don't need to check it again. Now for tan, we check again eat and tan. It will return false because this has an n here and this doesn't. So now we go to 8, ATE, that means true again. So 8. Whichever string we add, we make that as true only, because tan is not still in a group yet. So we don't mark it as true because we have to check it later also. Maybe inside the other group we can find it. Now we do for eat and nat, we get false and then false. So that means this group is done. Now the I was here and the j started from here to the end. Now we do I is here now. So the group is no actually I is not here because this is true. So we skip it. Now this is false. This is still false because all of the values are by default false. So now I is here. Now we check j for every pair except this one because this is the same. So j, 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 j. Now we assume tan is a new group of its own, TAN. Now we check every value which is false. We will check that. This is true already. That means these are in a group, so we don't check them. And this is the same as tan, so we don't check it with itself. This is true. So these two are left. So with these, check these two with tan. Nat and tan are anagrams. This function will give us true. So we add nat here also. Nat. And then bat and tan will not give us true, so we don't add it. This group is done. And also now this value is also true. So now I goes from here to here, but it is true, so skip it. I is here now, true, so skip it. Now I is here. So this becomes true because we have made a group of it now, BAT, but every other element is also true. So that means this string cannot find any partner, so we just close its group as like this, and then we make an array of this and then we return this. So this was the brute force solution. What we did was, first of all, we checked every pair with every pair. So that means O of n square due to 2 for loops. Now for every pair, we checked this function. This function does a traversal like we did in the last video. It by using a 26 size fixed array and the frequency, showing the frequency of for every character we do plus plus, and for every character of this we do minus minus, and in the end, if the frequency array of each character's value is 0, then that means that is an anagram. So for that process, we take O of k time and O of 26 space, which is constant, so we don't consider that. So this is the time complexity of this. That means for n square times, it will check n square number of pairs in the worst case, and for each pair, it will take this much time to calculate if they are anagrams or not. k is the max size of the string. Let's say all strings are 3 size, but there is one string. There are at least like 2 strings which are like BAT, TT, 5 size. So here k will be 5. K is the max worst case string size. So now obviously this is not a good solution. We have to find something better. So what to do now? We saw simply that checking every pair is just not feasible at all. So what we are going to do is, as usual, we will try sorting. Sorting plus also, wait, let me just erase this. We don't need this as well. Okay, so this is our array. What we need is, every anagram string has some pattern which is same. Like we talked in this video, that video also, EAT and also EAT, like these are having a similar pattern, just jumbled up order. So by the, and also by the time we reach this string, we need to remember that we have already seen this pattern before here and here. So what comes to mind? First of all, we need to use a map. This is a map. Okay. So this map will show the key and value. Now what will be the key and value? We see that in the end we get eat, t and 8 as a group. So the group, the array in which all the strings will be, that will be our value. An array list or array, whatever you want to do, and the key will be the pattern. Now how can you find a pattern? What is common in EAT and ATE? The thing is common is AET, or you can say TEA, whatever. But we cannot get this, but we can get this. What we're going to do is, we will just, instead of using that function which we did, the check anagram function, which will take O of k time each time. So what we want, we will just sort this string. Okay. So let's say we are doing traversal from here, I is equal to 0. So we sort the string. Now we get A, E, T. And we, in the map, we add A, E, T as the key. And in the value, which is the list, we add this. No, actually E, A, T. That means for this key, the key is the same. Because if we sort each string of the same pattern, this and this, we will get this only, because this is the alphabetical order. We as each string has a different order, so we try to fix one order, and then for that order we count how many keys of that order we can see if we sort them. So now it is added EAT. Now we go to this, we sort it, we get EAT again, even though they have different pattern, but after sorting they will be equal. So AET is also added here. No, actually it is TEA. Now we go to this, we get ANT. ANT. Now this is not ANT, so we make a new key, ANT, and in that key we add tan to the list. Now we go to ATE, we sort it, we get AET. AAT is here, so we add it to this list, ATE. Now we get NAT, we sort it, we get ANT, which is this. So we, by sorting it, we get the key where to add, and this is the value to add to the list. So we add it here, NAT. Now we are at BAT, we sort it, we get ABT. ABT is not here, so we add a new key, ABT, and we get BAT here. This is the key, this is the value. So in the end, we can just convert this map into an array or array list. In Java, there is a simple command for this, which is a new array list, and in bracket we write map values. New, we will just return new array list, and in bracket map dot values. So this method, in this we just did one traversal of the whole array of words. So that was O of n, and for each word we sorted it. Sorting takes O of n log n time, but the size of string we considered k in the worst case, so it will be k log k. Let me erase this. In the previous solution we had O of n square into k, O of n square into k, yes. In this solution we were able to reduce the n square to n, but we were not able to decrease this. We got extra thing, but still in the like higher level it is still better, because n square is worse rather than multiplying something. Multiplying a number to a number is, log is not that big of a number. Like if we take 2 power 31, then the log of it is just 31. So this is very small. So it is like, it is way better than, this is way better than this one, but we can make it even better. So what we are going to do is, this is the only thing that is going wrong, the sorting part. The sorting part is k and n log n, k log k. So what are we going to do? So now we are going to optimize it further. In the earlier solution, we sorted each string to check if that pattern in the, to add the pattern in the map. So now we will just change it a bit. Let's take this word EAT. Instead of sorting it and getting EAT, which will take k log k, we need to find a way to do this in one traversal. So that's in just O of k, we can make the pattern out of it. So how do we do it? We use another map, but instead of map, we use a frequency array. So what we're going to do is, let's make an array of 26 length. Okay, each index is equal to a character's frequency. So we write E is occurred 1, A has occurred 1 time, and T is occurred 1 time somewhere here. Now instead of storing an array as a key in the map, that is too much. So what we're going to do is we convert this into a hash key of ourselves. What we're going to do is just traverse this array and add a hashtag in between each number. So let's say this will be 1 hashtag 0 hash 0 hash 0, similarly 1 for this, and 0 0 0 1. So in the end we will get something like this: 1 hash 0 hash 0 hash 0. Why do we use hash? Let's take an example which is not from this array, just the pattern. If the pattern goes like, if A has occurred 1 time, and then B, no B, and C is 10 times, and then D is, let's say, 1 time. Okay, 1 0 1 A is 1 time, B is 10 times, and C is 1 time. Now take another pattern in which A is 1 time and B is 1 time and C is not there and D is 1 time. So in this pattern we can see 1 1 0 1 and 1 1 0 1. The pattern is same. So how do we figure out if 10 is different than 1 or not? Because if we just sum it up as a string, 1 1 0 1 and 1 1 0 1 look same. So that's why we add a hash, so that we can know this is 1, this is 10, this is 1, and this is 1 1 0 and 1, and not 10. It's actually 2 different digits. That's why we do this. So it's the same as the last solution, in which we will just save the pattern of each string. So E and T will go something like 1 hashtag 0 hash 1 hash 0 0 hash, and then 1. And then in this pattern we will, in this key, in the map, this is the key, we will store the array of EAT, TEA and ATE. And similarly for different pattern we will store TAN and NAT, and for different pattern we will store BAT. So this just helped us to reduce the sorting time complexity. So this will give us O of n, because we are still doing one traversal of the array, but instead of O of k log k, we will just get O of k. And for the space we get O of n, because the map, in the worst case, if each character has a different pattern, let's not consider this. Let's say this is group 1, group 2, group 3, group 4, group 5, group 6. So in the worst case we will have 6 keys in the map, so that's why O of n. So this is the most optimal solution. So that is it for today. Thanks for watching, and the next question will be top k frequent elements, I think.